Just plugging this in our calculator. You can see that. Sweet. That's the number we got. So I'm just going to copy it down. P max equals 0.00609. I'm gonna leave it like that. So that's that number. What we want to do is we sort of just want to use sig figs. So we can just rewrite this as, we can rewrite a few things, but let's just do this right here. 6.1, and that's 1, 2, 3. 1 value, 2 values, and 3 values to get back to 0. So it's just times 6.1, rounding this 9 up, times 10 to -3. And then the unit value we're using is PA, since we're finding pressure amplitude. So we can also just rewrite this as P max equals 6.10 MPa. And that's part A right there. So for part B, it's asking us if the intensity remains the same but the frequency is doubled to 512 hertz. How does this affect the pressure amplitude? So this is a chain question from part A. If we just look at the equation we pulled from the textbook, now I'll write it down in pen so it's easier. I equals P max squared over 2PV. It's saying the frequency is doubled. The intensity remains the same, intensity being this, but frequency being doubled. There is nowhere in this equation where frequency is applicable. And our options are the pressure amplitude is decreased, the pressure amplitude is increased, and the pressure amplitude is unchanged. If frequency doesn't play a factor, it's just not a factor in this. I don't know how you want to write it, but I'm writing it like that. Frequency is not a factor in this equation here, so it's just going to be unchanged.